Good evening, students. So let's try to go for some basic problem on hydrogen atom. Okay. So the first problem is that we have a radial wave function psi r10 is equal to a e to the power minus r upon a naught. Then find value of a such that r10 is normalized. Second question is we have to write the psi 100, the expression of psi 100. Third question is plot radial probability density versus R. Fourth problem is for this one, find the expectation value of R, expectation value of R square, expectation value of 1 by R. Fifth problem is find the expectation value of X, Y, and Z. Sixth one, find the expectation value of X square, Y square, Z square. So we have to work out each and everything for ground state energy eigenvalue. Okay. So let's try to go for normalization part. So what is our normalization thing? So that is R10 mod square R square dr. Obviously from 0 to infinity must be equal to 1. So when we will go for this one, you will go for 0 to infinity and we will take mod a square e to the power minus 2r a naught r square dr must be equal to 1. And now we have to solve this particular problem and we can easily solve it from the help of gamma integral. So when we will solve for the gamma integral, we have to put 2r upon a naught is equal to t, and then I can put r is equal to a naught by 2 t, and then dt is equal to a naught by 2 dt. Sorry, dr is equal to a naught by 2 dt. So now just look at this particular information that we can have mod a square and we will have a naught by 2 to the power cube. So a naught by 2 to the power cube will be outside, and inside e to the power minus t square dt must be equal to 1. Are you getting my point? So अब आप ये दिमाग में रखो, because in each and every problem we have to use this information. Okay? So what we have to do? जो भी r का पावर है उससे एक पावर इसके रेसिप्रोकल का बाहर आएगा. Isn't it? देख पा रहे हो आप? यहां r स्क्वायर है, yes, तो बाहर क्या आ रहा है? a नॉट बाई 2 का होल क्यूब. अगर r क्यूब रहता तो बाहर क्या आता?
a नॉट बाई 2 to the power 4.
अगर r 6 रहता तो बाहर क्या आता?
a naught by 2 to the power
7. Very good. Now, and what is this particular value? This is nothing but the gamma 3, and this is equivalent to what? Factorial 2. So you will have jitna t ka power rahega, that will be the factorial part. है ना? So you have this particular thing. So mod a square a naught by 2 whole cube factorial 2 is equal to 1. That is gamma 3 actually. And from here, we can easily calculate the value of a square into you have a naught cube by 8 into 2 is equal to 1. From there, we have value of a is equal to 2 upon a naught 3 by 2. Clear है ना? Just a minute.
डायरेक्ट फॉर्मूला भी हम यूज कर सकते हैं ना?
डायरेक्ट फॉर्मूला बोले तो
इंटीग्रेशन ऑफ 0 to infinity x raised to n e raised to minus alpha x dx.
आप जो भी यूज करो आपका आंसर सही आना चाहिए. ठीक है, मैं भी डायरेक्टिव फार्मूला यूज कर रहा हूं, मैं कोई अलग सा फार्मूला थोड़ी यूज कर रहा हूं, बट ओके, आप जैसे भी चाहो वैसे यूज कर सकते हो. ओके, सो व्हाट इज वैल्यू ऑफ नॉर्मलाइज्ड वेव फंक्शन? सो द वैल्यू ऑफ नॉर्मलाइज्ड वेव फंक्शन R10 is equal to 2 to the power a0 3 by 2 e to the power minus r upon a0. Okay, so this is normalized wave function. Now, what is your psi 100? Psi 100 क्या होगा? Obviously, you have to go for R10 into Y00. And what is Y00? So R10 is 2 upon a0 to the power 3 by 2, and Y00 is 1 upon root 4 pi. Okay? तो आप ये हमेशा ध्यान देना कि आपका क्या दिया हुआ एग्जाम में. 100 is basically, now this 2 can be cancelled and we have 1 upon pi a0 cube to the power half e to the power minus r upon a0. Obviously, r will from 0 to infinity. So now अगर आपका ये वेव फंक्शन है, क्यों मैं ये प्रॉब्लम आपको करवा रहा हूं ये आप दिमाग में रखो. If you have this particular wave function, then what is your variable? Then your variable is r, theta as well as phi. Are you people happy? अगर आपका ये वेव फंक्शन है 100, that means you have r, theta and phi, all three are variable. अगर आपने ये फंक्शन लिया हुआ है, then what you have to use? You have only your variable is r, and then r square dr will be part of integration of that particular r. Clear है ये? है ना? चलो. So this is your second problem. So let's go for third one. So I think I must remove this one ताकि हम सारा एक साथ कर सकें. चलिए. So next we have to plot the radial probability density. So what is your radial probability density? So radial probability density is basically R10 mod square R square. So if we will go for this, then this value is 4 upon a0 cube e to the power minus 2r upon a0 into r square. And we have to plot this particular function. So how we will plot? You can see that r tends to 0, this is 0. R tends to infinity, this is 0. So and obviously, there must be one maxima there. Then only it will be go 0 in particularly at the r is equal to 0 as well as r tends to infinity. So let's try to find that maxima, and that maxima is basically identified as most probable distance, where you will have maximum probability. So how you will get the most probable distance?
By calculating derivative.
Very good. Most probable distance. So how you will get most probable distance? So d rho upon dr must be equal to 0. So from there we have, so we will just calculate it. So 4 a0 cube I can take common. So you have 2r e to the power minus 2r upon a0. I have differentiated this one and I will keep this one constant. And then I will keep this one constant, r square. I have to differentiate this one. So that value will give me minus sign. And we have e to the power minus 2r upon a0 into 2 upon a0. सही लिखा हूं? Everyone is comfortable?
Yes, sir.
Yes, sir.
Okay. And what I will do, I will take lot of things common. So that value is a0 whole cube. So we can take 2r e to the power minus 2r upon a0 common. So this thing is 1. And here we have minus r upon a0 is equal to 0. This value cannot be equal to 0. This will be 0 at r is equal to 0. And this will be 0 at r is equal to infinity. We have analyzed all this thing. So obviously the finite value where this probability, this is going to be 0 at r is equal to a0. Okay. And obviously you will easily calculate. You can just check it that this is nothing but the maxima, and this is all the Bohr radius. So when you are just going to plot this particular thing, अगर आप इसे plot करोगे, then your plot will be very interesting. और ये शायद इसी बार था ना जस्ट के एग्जाम में, लास्ट ईयर एग्जाम में था आपका.
Yes, sir.
Okay. So if you are just going to plot it, the plot is very interesting. Okay, this kind of plot will be there, rho r versus r, and this value is nothing but a naught. Now, बोर साहब ने क्या कहा था? बोर साहब ने कहा था that your electron will be at the distance r naught. Classical picture is that your electron will be at the distance r naught if you are in the ground state. But here you can see there is finite probability that your particle or your electron will find beyond the a naught. है ना? बोर ने क्या कहा था कि सॉरी बोर ने जो आपको कहा था कि मोस्ट प्रोबेबल डिस्टेंस जहां पर पार्टिकल होगी, जहां पर इलेक्ट्रॉन होगा, वो किस ऑर्बिट में होगा? जहां पर ए नॉट है फॉर द ग्राउंड स्टेट. सो दिस इज एट ए नॉट. बट यू कैन सी इसके बियॉन्ड भी पार्टिकल के होने की प्रोबेबिलिटी है. दिस इज वेरी इंटरेस्टिंग. और इनफैक्ट ए नॉट के बियॉन्ड पार्टिकल की होने की प्रोबेबिलिटी ज्यादा है. व्हाई? बिकॉज दिस इज स्क्यू सिमेट्रिक. दिस इज स्क्यू सिमेट्रिक टुवर्ड्स राइट. मीन्स ज्यादा एरिया इस पार्ट में है. ओके, एंड लेस एरिया विल बी इन दिस पार्ट. सो एक बार एग्जाम में आया था, व्हाट विल बी प्रोबेबिलिटी दैट इलेक्ट्रॉन विल फाइंड बियॉन्ड आर नॉट? What will be probability that electron will find beyond R naught? So how you will find this particular thing? अगर आपको ये निकालना होगा, probability such that R is greater than A naught.
Sir,
हाँ बताओ.
sir, less than a naught के लिए find करके 1 से subtract
एक ही बात हो गया. लेस देन फाइंड करोगे तो उसके लिए भी यही चीज होगा. इंटीग्रेशन तो करना ही पड़ेगा आपको. लेस देन फाइंड करके फिर उसको क्यों करोगे? यहीं से आगे नहीं कर लोगे क्या?
हाँ सर, कर सकते हैं. दोनों तरीके से कर सकते हैं.
दोनों तो एक ही चीज है. दोनों में आपको इंटीग्रेशन, कहीं पर गामा इंटीग्रेशन तो लगेगा नहीं, है ना? सो व्हाट विल बी दिस इंटीग्रेशन? यू हैव टू गो फ्रॉम a naught to infinity, and this value is r10 mod square r square dr. आप जब इसे कैलकुलेट करोगे तो a naught to infinity, and what is this value? This value is 4 upon a naught whole cube e to the power minus 2r upon a naught r square dr. Okay, so कैसे इसे इंटीग्रेट करोगे? How you will integrate it? Is that you will use gamma integral here? No, you have to just go for
No.
integration by parts. Okay, you have to go for integration by parts. And then you can find this is nothing but 68% or 0.68%. So this area is 0.68. So this area is what? 0.32. So this has more probability. So particle beyond the A naught has more likelihood, है ना? इस डायरेक्शन में पार्टिकल के होने की प्रोबेबिलिटी ज्यादा है, वहां पर होने का ज्यादा चांस मिलेगा. एंड ऑब्वियसली इफ दिस इज 68, then this is 0.32. That means this wave function is normalized, so why we can use it as a probability density. क्लियर है? कहीं गलती से आर स्क्वायर छोड़ मत देना, अदरवाइज इट विल क्रिएट अ हैवॉक, है ना? चलो, कुछ पूछना है यहां तक? एवरीवन? कोई रिस्पॉन्स नहीं. चलो आगे बढ़ते हैं. So next problem is what is your expectation value of r? What is your expectation value of r? इसमें क्या करोगे, दोनों वेव फंक्शन यूज हो सकता है या फिर सिर्फ एक यूज हो सकता है?
सर दोनों
दोनों ही यूज हो सकता है. So first we will use the radial part and then I will use the total also and we will see दोनों से same answer आ रहा है कि नहीं. So what is expectation value of r? Is r10 mod square r square dr. कहां से कहां तक जाएंगे? 0 to infinity. And we have to take it normalize one. तो ये क्या हो जाएगा? This value is 4 upon a naught cube. अंदर में क्या आ जाएगा? r cube e to the power minus 2r a naught dr. So 0 to infinity. इसे आप इंटीग्रेट करोगे, व्हाट यू विल गेट? 4 अपॉन ए नॉट क्यूब इनटू बाहर क्या आ जाएगा बताओ? ए नॉट बाई 2 टू द पावर 4 फैक्टोरियल 3. ठीक है. एंड व्हेन यू विल जस्ट कैलकुलेट इट, आई थिंक यू विल गेट द वैल्यू 3/2 ए नॉट. सो द एवरेज वैल्यू इज ऑब्वियसली मोर देन ए नॉट. होना चाहिए. क्यों होना चाहिए जरा बताओ? मैं कैसे कह रहा हूं कि मैं सही मेरा आंसर है? Suppose this is your rho r and this is your r and this value is a naught. We know this particular thing. Where is expectation value of r? Is here, है ना? This is your expectation value of r is equal to 3/2 a naught. मैं कैसे कह सकता हूं कि ये सही है, गलत नहीं है?
Right side part has a more probability.
Yes, right side part has more probability. So your average value will shift towards right from this particular point, है ना? उसके right ही होना चाहिए, isn't it? 0 से a नॉट की होने की प्रोबेबिलिटी ओनली 32% है और a नॉट से इंफिनिटी होने की प्रोबेबिलिटी 68% है. सो ऑब्वियसली तो a नॉट के रेफरेंस में माय एवरेज वैल्यू शुड बी टुवर्ड्स राइट, इजंट इट? ओके. अब इसी प्रॉब्लम को अगर मुझे टोटल वेव फंक्शन से करना हो तो क्या होगा? वी विल गो फ्रॉम 0 टू इंफिनिटी, 0 टू पाई, 0 टू 2 पाई r और यहां क्या ले लेंगे? साई 100 मॉड स्क्वायर r स्क्वायर और क्या होगा? साइन थीटा डी आर डी थीटा डी फाई, इजंट इट? क्योंकि जैसे आप टोटल वेव फंक्शन ले रहे हो, योर वेरिएबल इज आर थीटा एंड फाई. ये तीनों के तीनों ही आपके वेरिएबल होंगे. ओके. एंड व्हेन देन व्हाट विल हैपन? So what is your psi 11? You have to remember that thing, that is pi a naught cube. स्क्वायर करेंगे तो ये आ जाएगा. And now the radial part will be r cube e to the power minus 2r upon a naught dr 0 to infinity, and the angular part will be 0 to pi, 0 to 2 pi, and that value is equal to sin theta d theta d phi. So what will happen? इसकी वैल्यू कितनी हो जाएगी बताइए?
4 pi.
4 pi. This value is 4 pi. So you have 1 upon pi a naught cube into, इसकी वैल्यू फिर से देखोगे तो then this value is a naught by 2 whole cube factorial 3 into 4 pi. देखो सेम आ रहा है क्या आंसर? सेम आ रहा है या नहीं? जस्ट चेक इट.
Yes, sir.
यस. हाँ बताओ.
A naught by 2 4 नहीं आएगा पार?
ए नॉट टू द कहां पर क्या कर दिया? कहां 2 है?
Sir,
Sir,
a naught by 2 की power 4.
हाँ सॉरी, दिस विल बी 4. हाँ गुड, थैंक यू. ए नॉट बाई 2 टू द पावर 4 ऑब्वियसली 4 आएगा. ठीक है, क्लियर है ये, है ना? सो ऑब्वियसली ये आपके ऊपर चॉइस होता है कि आप कौन सा वेव फंक्शन लेते हो, और एग्जाम में जरूर ध्यान में देखना है कौन सा वेव फंक्शन दिया हुआ है। तो पता चला कि वेव फंक्शन ये दिया हुआ है और आप इसमें कर रहे हो, तो ये वाला पार्ट एक्स्ट्रा बच जाएगा, है ना। दिस पार्ट, दिस पाई विल बी एक्स्ट्रा देयर। सो ऑब्वियसली आपको वेरिएबल्स को बहुत ही ध्यान से रखना है। ओके चलो, सो अब बाकी प्रॉब्लम को मैं एक ही तरीके से करने की कोशिश करूंगा। आई हैव जस्ट गिवन यू इंट्यूशन, है ना। सो हम लोग ने क्या क्या देख रखा है उसका मैं यहां लिस्ट भी आपका तैयार कर दे रहा हूं। सो मोस्ट प्रोबेबल किस पॉइंट पर है, ए नॉट पर। एवरेज वैल्यू ऑफ आर 3/2 ए नॉट। ओके, let's try to calculate average value of r square. So let's try to go for this. चलिए, so when we will go for average value of r square, then this is r square, this is r square. So what will happen? This will be 0 to infinity, and this is r to the power 4 e to the power minus 2r upon a naught dr, and here is 4 upon a naught to the power cube. ठीक है ना? Again, what will be this integration? 4 upon a naught cube, यहां से क्या आ जाएगा बताइए? a naught by 2 to the power 5 and factorial 4. Now if you will calculate it, just calculate करो. I think you will get 3 a naught square will be the answer. आ रहा है क्या? Yes? Yes. So you have expectation value of r square is 3 a naught square. चलिए, नेक्स्ट हमें क्या निकालना है? 1/r का एक्सपेक्टेशन वैल्यू, है ना। So let's try to go for 1/r. So if we are going for 1/r, so this is 1/r and this will be changed to 1/r. Okay. So when we will calculate it, let's try to go for this one. Simple integration आपका अगर clear है तो ये सारे प्रॉब्लम आराम से हो जाएंगे, है ना। चलिए, so this value is equal to 0 to infinity, and again we have 4 upon a naught cube, and we have 1r is cancelled, so r is there, e to the power minus 2r a naught dr. So we have 4 upon a naught cube. क्या आ जाएगा वैल्यू हमारा? a naught by 2 to the power square factorial 1. देखो तो क्या आ रहा है? 1 upon a naught आ रहा है क्या? Yes. So this value is nothing but what? 1 upon a naught. Now you can see it's a very interesting that 1 upon expectation value of r is not equal to 1 upon expectation value of 1/r, है ना। 1 upon expectation value of r is what? 1 upon 1.5 a naught, and which is not equal to 1/a naught. Clear है? And this is all about, है ना। पता चला कि ये निकाल दिए और 1/2 से डिवाइड कर दिए इसको निकालने के लिए। ये सारे ब्लंडर एग्जाम में मत कीजिएगा। ओके, यू हैव टू जस्ट गो एंड सॉल्व द प्रॉब्लम विथ ऑल प्रॉपर कैलकुलेशन। क्लियर है ये?
Yes, sir.
ठीक है, चलो। सो दिस इज अ वेरी ट्रिवियल, मैं इसको इसलिए कहूंगा कि सिर्फ आर ही इन्वॉल्व है। लेट्स ट्राई टू गो फॉर एक्सपेक्टेशन वैल्यू ऑफ x, y and z. So when we will go for expectation value of x, then please tell me we should go for only a radial part or total wave function?
Total wave function.
Total wave function. And then this expectation value of x is nothing but r क्या होगा sin theta cos phi. And you have to actually calculate this one. So when we are going to calculate this one, then we have to take psi 100, and that value is 1 upon pi a naught cube to the power 1 by 2 e to the power minus r upon a naught. है ना? So you can see. So when we are going for this one, then what will happen? Then we have integration r square e to the power minus 2r a naught dr 0 to infinity 1 upon pi a naught cube. And here we have sine square theta d theta 0 to 2 pi. And we have 0 to pi, not 2 pi, and 0 to 2 pi cos phi d phi. Now you can see cos phi d phi 0 to 2 pi is equal to what?
0.
0. So there is no need to do all this thing. है ना यहीं पर calculate किया that value is 0. So your expectation value of x is equal to 0. So now you can also claim, I can also claim my expectation value of y is also 0. Isn't it? क्या मैं क्लेम कर सकता हूं कि एक्सपेक्टेशन वैल्यू y भी 0 होगा?
Yes, sir. Yes, sir.
है ना? एक्सपेक्टेशन वैल्यू y के लिए क्या करेंगे? This is x, we will take y, and here we have what? Sin phi. And here you will go for sin phi. Then expectation value y is also 0. Sin phi d phi 0 to 2 pi is again 0. Let's calculate expectation value of z. So when we will calculating expectation value of z, that is r sin theta. Sorry, r cos theta, not sin theta, r cos theta. है ना? So this is your expectation value of z. So when we will go for this, then we have 1 upon pi a naught cube. The radial part will remain same, r into r square e to the power minus 2r a naught dr. And here we have sin theta cos theta d theta 0 to pi, and we have d phi. Now sin theta cos theta d theta 0 to pi is again 0, isn't it? I can write multiply by 2, divide by 2, and this is sin 2 theta d theta 0 to pi is also what? 0. So you can easily check this value is 0. So expectation value of z is also 0. Look at why this thing are coming into the picture. This is very interesting. Let's try to calculate the expectation value of x square, y square, and z square. यहाँ तक क्लियर है ना?
Yes, sir.
Okay. Let's try to calculate the expectation value of x square. देखते हैं क्या आता है. Obviously that should be not 0, है ना? So here we can have another conclusion that expectation value of x is equal to y is equal to z is equal to 0. And now let's try to go for basically expectation value of x square. So when we are talking about expectation value of x square, that is r square sin square theta cos square phi. We have to calculate expectation value of this one. So what will happen? Again, we will have to go for what? Total wave function. So when we will go for total wave function, that is 1 upon pi a naught cube integration this r square and one another r square is r to the power 4 e to the power minus 2r a naught dr 0 to infinity, and then we have sine cube theta d theta 0 to pi, because you know in the spherical polar coordinate we have sine r square sine theta d theta. So this is that sine theta, and here we have cos square phi d phi 0 to 2 pi. And when you are going to calculate this one, then what we will get? We will get 1 upon pi a naught cube. What will be this integration? What will be this integration?
A naught by 2 to
A
the
naught
power
by
5.
2 to the power 5, and you
4
have gone factorial 4 into what will be this integration? बहुत बार कर चुके हैं.
2 by 3.
4 by 3.
2 by 3.
अरे यार. What will be this integration? This integration 2 by 3 or 4 by 3?
So pi.
ये इंटीग्रेशन पाई होगा. हाँ, कैसे इसे करोगे? Cos square phi is equal to what?
1 plus cos 2 theta by 2.
Cos 2 phi है ना?
2 phi.
2 phi. Okay, so that value is equal to pi. Obviously that value is pi. Cos 2 pi is 0 to 2 pi is 0, so only will remain 2 pi by 2, that is pi. क्या आ रहा है वैल्यू? जरा देखिए तो. वेरी इंटरेस्टिंग. क्या आ रहा है? This pi is cancel. You have a naught square into you have 2 to the power 5 into 2 to the power 2 into 2 to the power 2. Sorry.
E naught square.
Huh? A naught square. So this is 4 into 3 into 2. है ना? And here 2 to the power 2 upon 3. So this 3 will gone. So 2 to the power, so this will be also gone. And
A naught square by 4.
so यहाँ पर क्या हो जाएगा? A naught square is there. So obviously, so ये 3 चला गया, and this is equivalent to 2 to the power 5, है ना?
Yes, sir.
2 square cube, so that is all these thing will be cancel out. So you have A naught square. Very interesting. Look at this physics. ये physics देख सकते हो, है ना? We will discuss it. क्या हो रहा है? Now, what will be expectation value of y square? You will also get A naught square, and expectation value of z square you will also get A naught square. Don't worry. Y square में क्या अंतर आ जाएगा? Here you will get sine square phi, and everything will be same. So again, sine square phi d phi will be the same of your 0 to 2 pi, है ना? So that will you will get A square. In the z square, you will get this one is same, and here you have. So I can calculate z square. So z square के लिए क्या मिल जाएगा हमें? Let me use this one. So let's try to y square के लिए same आपका आ जाएगा. So let's try to calculate for z square. So when we are going for z square, and we have basically z square is nothing but we have r square cos square theta, है ना? Now this thing is remain same, and here we have cos square theta sin theta d theta, and here we have d phi. Okay. So now when we are going to calculate this one, this will be 1 upon pi a naught cube. This value is equal to again a naught by 2 to the power 5 factorial 4. What will be this integration? बहुत बार कर चुके हैं ऐसा, ये इंटीग्रेशन भी अभी तुरंत किया है हमने।
पाई माइनस 4/3
पाई माइनस
पाई
4/,
माइनस
ये क्या है?
आंसर उसको कन्वर्ट कर देते हैं 1 माइनस साइन स्क्वायर थीटा
सो
में।
दैट वैल्यू, ये तो होगा 2 पाई है ना, दिस इज 2 पाई एंड व्हाट इज दिस वैल्यू?
2/3.
क्या क्या बोल रहा है यार। पुट cos theta is equal to t, then sin theta d theta minus sin is equal to dt. Okay,
2/3.
2/3, very good. So that value is 2/3. Now you can put it, okay, and that value is 2/3. And now you can easily check क्या आ रहा है वैल्यू, जरा देखो तो। So you have pi is cancel. So you have a naught square 2 to the power 5 4 into 3 into 2 into 2 by 3 into 2.
Square getting.
Huh? Exactly. A naught square. So that value is again expectation value of z square is also a naught square. Look at what is going to happen. Now you can see, look at. So what we have expectation value of x square is equal to expectation value of y square is equal to expectation value of z square is equal to a naught square. We have expectation value of x is equal to y is equal to z is equal to 0. And why this thing is coming? Because we are working for the wave function, which is basically spherically symmetric in nature. What is spherical symmetric in nature? Means if the wave function is not actually function of theta and phi, they are not depending on a theta and phi. So if they are not depending on theta and phi, they are only depending on the r part. So whatever be the s orbital, for s orbital, either you can have 1s or you can have 2s or you can have 3s, where L is equal to 0 is basically spherically symmetric. The wave function is spherical symmetric. So if your wave function is spherical symmetric, you cannot differentiate between x-axis to y-axis to z-axis. You can change your x to y, y to z, the symmetry will remain same. So why you are getting exactly expectation value x square is equal to y square is equal to z square is equal to a naught square. Are you getting my point? And look at here one very interesting information. Look at this is very interesting. So now if you are into the spherical symmetric wave function, means L is equal to 0 I am talking about. If I am talking about L is equal to 0, that means M must be equal to 0. And this is all about spherical symmetric. A spherical symmetric wave function. And if you have a spherical symmetric wave function, you cannot differentiate between x, y, and z. So what you can do, you can also not differentiate between Lx, Ly, and Lz. Isn't it? You cannot differentiate between Lx, Ly, and Lz. And so what will happen? So whatever be the direction of angular momentum, suppose this is my angular momentum. What I can do, I can take this direction as my z direction. So I can write my angular momentum is nothing but my Lz, because I cannot differentiate my x direction, y direction, or z direction. So what will happen for s is equal to 0? In spite of you have Lx Ly is equal to I h cut Lz. That means in general you cannot measure x component, y component, z component simultaneously in general, but when you are going for the spherical symmetric wave function, that means for L is equal to 0 part, you can measure Lx, Ly, Lz simultaneously. Why? Because there is nothing called x direction, nothing called y direction, nothing called a specific z direction. Any arbitrary direction I can take my z direction, and that may be my Lz, and that if I know Lz, I know Lx, I know Ly. Are you getting my point?
Sir, this thing one more time, please, sir.
मैं ये कह रहा हूं कि इन जनरल Lx Ly कम्यूट नहीं कर रहा है, ठीक है? मैं अब एंगुलर मोमेंटम अलजेब्रा में जा रहा हूं. Lx Ly is not going to commute. That means you cannot measure Lx Ly or Lz simultaneously.
Yes, sir.
Yes, but if you have a spherical symmetric wave function, then you cannot differentiate between x direction, y direction, and z direction, isn't it?
Yes, sir.
Okay. So if you cannot differentiate x direction, y direction, z direction, you can assume always your L vector is along Lz direction. Nahin?
Yes, sir.
Yes. So if you can assume your L vector along Lz direction, then whatever be your x direction is also your z direction, is also your y direction.
Yes, sir.
जैसे आपके पास, इसको इस तरह देखो, अगर आपके पास ये स्फेयर है, ये x y है, ये z है, तो आप इसे आप x लिख रहे हो, इसे y लिख रहे हो, इसे z लिख रहे हो, मैं इसे z, इसे x, इसे y भी लिख सकता हूं, isn't it? Because
Yes,
if
sir.
I am changing the symmetry, x को y से चेंज कर देते हैं, y को z से चेंज कर देते हैं, इस स्फेयर के सिमेट्री में कोई चेंज होगा क्या?
No, sir.
नो. सो वाई, याद होगा कि आपने जब मोमेंट ऑफ इनर्शिया लिया था तो हमने वो डायमीटर लिया था जो अलोंग जेड एक्सिस है, या फिर डायमीटर को ही जेड एक्सिस मान लिया था, है ना? किसी भी आर्बिट्री डायमीटर को मैंने जेड एक्सिस वाला निकाल लिया, बाकी सबके अराउंड भी वही मोमेंट ऑफ इनर्शिया होगा. रिमेंबर दैट थिंग?
Yes, sir.
है ना? फ्रॉम एनी डायमीटर यू हैव सेम मोमेंट ऑफ इनर्शिया. सो सिमिलरली हियर फॉर एनी डायरेक्शन इज योर जेड डायरेक्शन. So in this special case, even if your angular momentum is not going to commute due to a spherical symmetric behavior of wave function, you can measure Lx, Ly, Lz simultaneously.
Yes, sir. समझ गया, sir.
समझ गए? So this is a wonderful thing for a s orbital, means I am talking about L is equal to 0 and m is equal to 0. क्योंकि L is equal to 0 और m is equal to 0 जैसे ही आ रहा है, तो वो वेव फंक्शन क्या है? That is 4 pi, root under 4 pi, and this is not a function of theta and phi. So इसके ऊपर कोई भी थीटा और फाई का ऑपरेटर को ऑपरेट करोगे, you will get the same thing. नहीं?
Yes, sir.
कोई भी थीटा और फाई का ऑपरेटर को ऑपरेट करो, आप Lx को ऑपरेट करो, Ly को ऑपरेट करो, you will get same thing. Lz को ऑपरेट करो, you will get same thing. Isn't it?
Yes, sir.
So why? You can measure it simultaneously. So this is wonderful thing, and this thing is given into Griffith. I will send you the photo of that particular page also, such that you can read it very comprehensively. Okay?
Yes, sir.
So from my side, this is a one part of hydrogen atom. It will take one more class where we will go for application of postulates on hydrogen atom also, and some more problem. ठीक है? आज के लिए इतना ही रहने देता है. Everyone is comfortable?
Yes, sir.
So आपकी क्वांटम मैकेनिक्स मोर और लेस फिनिश होने जा रही है. सो आप रिवीजन शुरू करते जाइए, है ना? और आपके लिए सबसे अच्छी बात है कि एग्जाम के 2 महीने पहले खत्म हो जा रहा है क्वांटम मैकेनिक्स लगभग, है ना? सो आपके पास एनफ टाइम है प्रैक्टिस करने का, टेस्ट देने का, ठीक है? सो प्लीज गो पॉजिटिवली, है ना? ओके, थैंक यू।
Thank you, sir.